So here we have a function f of three variables x, y, and g, and we are given with this particular expression where alpha, beta, and gamma are constant. We need to show that the following equation holds true. So let's begin. So here we are given the expression x squared divided by alpha squared plus the function f added to y squared divided by beta squared plus the function f plus z squared divided by gamma squared plus the function f. So this is equals to 1. Let's label this as equation number 1. So what we'll do, we'll take the partial derivative on both sides with respect to x. So we have partial with respect to x of x squared divided by alpha squared plus f. Plus, we'll take the partial with respect to x of the second term, which is y squared divided by beta squared plus f. Plus, partial with respect to x of z squared divided by gamma squared plus f. So this will be equals to partial with respect to x of the constant 1. Now we'll have to use the quotient rule to find out the derivative, partial derivative of each of the terms on the left hand side. So let's begin. So for the first term, we have in the numerator alpha squared plus the function f squared. In the numerator, we have alpha squared plus f multiply to partial with respect to x of x squared minus x squared times partial with respect to x of alpha squared plus f. So this is the first term. Then in the second term, we have beta squared plus f whole squared. We have beta squared plus f multiplied to partial with respect to x of y squared minus y squared times partial with respect to x of beta squared plus f plus partial derivative of the third term, which will be gamma squared plus f. In the numerator, we have, so there's a square here as well. So this will be gamma squared plus f multiplied to partial of z squared divided by partial of x with respect to x minus z squared times partial with respect to x of gamma squared plus the function f, which will be equals to 0 because partial derivative of a constant 1 with respect to x is 0. Now let's simplify the terms in the numerator of each term. So we have alpha squared plus f multiplied to partial derivative of x squared. So that will be 2x. So I'm going to divide it by the denominator, which is alpha squared plus f whole squared minus. So here we have x squared divided by alpha squared plus f whole squared. Now we'll have to take the partial derivative of alpha squared, which is 0, times partial of f with respect to x. So that will be partial of f with respect to x. Plus, now partial of y squared with respect to x will be 0 because y will be treated as a constant whenever we're taking the partial derivative with respect to x. So that means this first term in the numerator is 0. So we were left with negative y squared divided by beta squared plus f squared multiplied to, so partial derivative of beta squared with respect to x will be 0 because beta is a constant. So we are left with partial of f with respect to x. Similarly, this term will go to 0 because z squared will be a constant whenever taking its partial derivative with respect to x. So we are now left with negative z squared divided by gamma squared plus f whole squared. So this will be multiplied to partial derivative of gamma squared plus f will be simply partial of f with respect to x. So this is equals to 0. So what we can do from the second, third, and fourth term, we can take partial of f with respect to x as the common factor. So that means now we have, so here in the first term, so alpha squared plus f from the numerator and 1 alpha squared plus f from the denominator goes away. So this leaves us with 2x divided by alpha squared plus f minus, we'll take partial of f with respect to x as the common factor. So this will get multiplied to x squared divided by alpha squared plus f whole squared plus y squared divided by alpha squared plus f whole squared plus z squared divided by gamma squared plus f squared. Right? So this will be equals to 0. So we can take this term to the right hand side. So we will have this will be equals to 0. Now what we'll do, we will let this entire expression within the parentheses to be equals to lambda, such that we have 2x divided by alpha squared plus f equals to partial of f with respect to x multiplied to lambda, where we have considered lambda to be equals to x squared divided by alpha squared plus f squared plus y squared divided by beta squared plus f squared plus z squared divided by gamma squared plus f squared. Fine. Now we isolate partial of f with respect to x, so this will be equals to 2x divided by lambda times alpha squared plus f. So let's label this as equation number 2. So what we'll do, if we again consider equation number 1 and take the partial derivative with respect to y, then using the same method, using the same steps, we will get partial of f with respect to y will be given by 2 times y divided by lambda times beta squared plus f. So this will be equation number 3. And we have partial of f with respect to z, that will be given by 2z divided by lambda times gamma squared plus f. So you can check that out, the calculation. It's a very simple one. Now what we'll do, now that we have 2, 3 and 4, now we will use it to prove our given expression. So let's do that. So let's start with the left hand side. So here we'll have partial of f with respect to x whole squared. So we'll use this expression. So we'll get 4 times x squared divided by lambda squared multiplied to alpha squared plus f squared. This will get added to partial of f with respect to y squared. We will use this expression to get 4y squared divided by lambda squared multiplied to beta squared plus f squared. And for the third term, we have partial of f with respect to z squared. So that will be 4 times z squared divided by lambda squared multiplied to gamma squared plus f squared. So we will take 4 over lambda squared as the common factor. So this will get multiplied to x squared divided by alpha squared plus f squared plus y squared divided by beta squared plus f squared plus z squared divided by gamma squared plus f squared. But we have already considered that this value within the expression to be equals to lambda. So we have now 4 times lambda squared multiplied to lambda, which is going to give us 4 over lambda. Now we'll move on to the right hand side. Now let's start with the right hand side. On the right hand side we have 2. This will be multiplied to, we have x times partial of f with respect to x. So this will make it 2x squared divided by lambda times alpha squared plus f added to y times partial of f with respect to y. So that will be 2y squared divided by lambda times beta squared plus f plus z times partial of f with respect to z will make it 2z squared divided by lambda times gamma squared plus f. Now what we can do, we can take 2 over lambda as a common factor from each of the 3 terms, and we will take it out to get 4 over lambda. That means within the parentheses, now we have x squared divided by lambda squared plus f plus y squared divided by beta squared plus f plus z squared divided by gamma squared plus f. Now in a problem, we already provided this expression as equals to 1. So we have 4 over lambda multiplied to 1, which is equals to 4 over lambda. Now that means on the right hand side as well, we have obtained 4 over lambda. So that means the given equation is true.